A forklift can lift lots of weight without tipping over, thanks to its design. Each part is crucial to keep the functioning and operators safe while operating a forklift. These parts vary depending on the model. For example, some forklifts are more suited for rugged terrain while others are not. These are the basic parts of most forklifts. Load backrest. This part keeps the load from shifting backward. Overhead guard. This section of the forklift protects operators from a load if it falls. Carriage. The carriage is the base of the forklift and is fixed on mast rails to easily move up and down. Forks. These are the prongs that carry loads. Mast. The mast raises and lowers the load. It also has interlocking rails that provide horizontal control. Counterweight. This weight is used to stabilize the forklift and keep it from tipping over. Power source. Forklifts can be powered by fuel cells, propane gas, gasoline, diesel engine, or batteries. Truck frame. The frame is the base of the machine and all parts are attached to it. Tires. Forklifts can use pneumatic tires, normally used outdoors, or solid tires, sometimes called cushion tires, that are used both indoors and on hard, flat surfaces. The most important parts of the forklift are the hydraulic system, chain pulley system, and forklift controls. Both systems and the controls are vital for the forklift's power and lifting abilities. We'll dive into each part below. The machine's forks that carry the load are attached to the frame with a pair of roller chain pulleys. The pulley's fulcrum is a gear, found at the top of the mast. Here's how the roller chain pulley system works. Hydraulic pistons push the masts up. Gears on the mast push against the roller chains. The masts move up and pull the fork up. Since one side of the chain is attached to the immovable frame of the forklift, that mast can only move up if the gear rotates clockwise and pulls the forks up. This system allows the fork to lift higher than it would if the forklift relied solely on the hydraulic system. If it only used hydraulics, the forklift would need taller cylinders to reach the same height. Taller cylinders require more materials, stronger pumps, and higher pressure limits that can shift the forklift's center of gravity, increase the risk of tipping, and overall, increase the level of danger when using forklifts. A forklift's main controls are for steering and lifting. Although it sounds simple, understanding how both of these work helps an operator safely and efficiently get the job done. Steering controls. The steering controls are similar to ones you would find in a golf cart or a regular car. A forklift has an acceleration pedal, brake, steering wheel, forward gear, and reverse gear. However, forklifts use rear wheel steering, meaning that the steering wheel controls the rear wheels. This works better for forklifts, and gives operators greater precision and rotation control when carrying a load. Lifting controls. The lifting controls use one lever for moving the load up and down and another for tilting the load back and forth. Pushing the lifting lever forward moves the load up while moving it backward moves it down. Tilting, however, is a bit more complex. The tilt function involves two more hydraulic cylinders found at the base of the masts. Here's what happens when the tilt lever is moved in both directions. Forward. Air is pumped into the chamber. The rise in pressure level pushes the piston head, and results in the mast tilting away from the frame. Back. Air is gently released from the chamber and air is pumped in the other pair of cylinders we mentioned earlier from the hydraulic system. The mast leans towards the vehicle when those pistons push that pair of cylinders forward. The front wheels of the forklift are the fulcrum point. The rear of the forklift has counterweights to help offset the weight of the load. Remember, a loaded forklift is less stable, as all the weight is in the rear. The opposite can be said about the loaded forklift, which is more stable. The counterweight and load are balancing, adding additional stability. In order to understand this lesson, you need to know certain terminology we are going to use. And the keyword is center of gravity. The center of gravity, CG, is the point at which load is concentrated. If the center of gravity remains inside the triangle, the truck won't tip. Combined center of gravity is the center of gravity of the truck, affected after the loading, and any movement by additional load center of gravity. As long as the combined center of gravity is within the stability triangle of the truck is stable, otherwise, the truck can tip.
A stable forklift has a center of gravity that is low and close to the middle of the forklift, well within the stability triangle. Here are the factors that affect the center of gravity. Load weight is a major factor. As load weight increases, the center of gravity moves toward the load. Load balance affects the side-to-side location of the center of gravity. A load that is not centered will move the center of gravity to the side where the load is heavier. Load height is also a big influence on stability. The higher a load is raised, the more unstable the truck becomes. With a load raised high, it may only take a small bump, a slight turn, or a quick stop to tip over the forklift. Inclined or uneven surfaces move the center of gravity in the direction of the downward slope. Momentum has a great influence on the truck when it is in motion. Acceleration will move the center of gravity toward the rear of the truck, and deceleration, such as when braking, will move the center of gravity toward the load. Turning will move the center of gravity toward the outside of the turn. The faster a turn is taken, the more unstable a truck becomes.
The forklift data plate is also known as data tag, or capacity plate, is a very important piece of equipment that provides you with critical data. It is mandatory for operators to understand the information provided on the data plate to ensure safe operations. It must be kept in mind that each forklift has a different capacity limit and other specific operational parameters. On the top, we find the model as well as the serial number. The type of mast and its tilt. Here we have a 6.5 degrees tilt for this particular forklift. We also see the attachment for the forks. Here we have a side shifter. It is an electric model with a 36-volt battery with a capacity of 880 amp/hour. We can see the size of the front and rear tires with their type. Also, we can see the weight of the vehicle without a battery, and next to it we see the weight of the battery alone. When we talk about lifting capacity, we must understand two important points that have a dramatic effect on the stability of the vehicle. First, the higher the lift, the less the safety capacity of the vehicle. Second, the further you get away from the mast, the less the capacity, since the center of gravity is moving forward. Here we have a forklift with a capacity of 3,000 pounds if the center of the load is placed 24 inches from the mast, and if the center of the load is placed at 30 inches from the mast, the capacity is reduced to 2,000 pounds.